This time I have a Sony. This is a TC730 reel-to-reel auto reverse, 6 heads. It'll record in both directions, and this one's a little slow. Oh, can I say that? Can I say it's slow? How about its speed is a little bit low? Yes, this one has a servo problem that we're going to have to deal with. There are other problems with this too. It has a problem with the auto shut-off. We're going to deal with that. And the controls are also dirty, which we're going to also have to deal with that. Anyway, I don't want this to be a marathon, but let's get started. I have a Sony reel-to-reel. This one is a TC730, and the speed on this is claimed to be slow. I have 4 kilohertz tone tape on here. Let's check the speed. Sounds a bit low to me. Frequency counter showing 3.48 kilohertz. Now, this is a servo controlled unit, auto reverse. I don't think there's anything on the other side of this tape. Just, it's a 6 head machine. They kind of copied Akai's design, like from the GX260, for example. GX260 has 6 heads. It has 2 erase heads, 1 for each direction, 2 record heads, 1 for each direction, and 2 playback heads. But does this... Wait a minute. I only see 4 heads on this thing. Is this a combination erase and record? This is an erase record combination. That's 2 heads in one, looks like. Yeah, that's what that is. That's a combination erase and record head and playback head. My Akai has got separate heads. Well, I guess the erase and record heads are just side by side, but they're the glass heads on the GX260. Other than that, these share a lot of similarities. Anyway, I got to pull this apart. This is servo control, this one. So we'll rip this apart and dig into the servos and see why it's not going the right speed. So this one uses the frequency generator. I've got some schematics here and some paperwork to try to explain to you guys how it works. But simply put, there's a frequency generator on the motor. Generates a tone that's amplified, runs through the comparator circuit, and generates an error voltage which is applied to Q901. Q901 is basically operates like a variable resistor. It changes its resistance across this bridge, which effectively changes the amount of power that's allowed to pass through it, because the bridge is going to pass the AC power through here. It's an AC motor. It's going to affect the voltage going through the bridge effectively by changing the resistance here. It changes because it's going to pass AC. It's going to change the effective voltage, which is going to change the effective amount of torque, which will change the speed of the motor. That's in a nutshell how it works. And they kind of explain it here, right? When the motor speed becomes faster or slower than intended, due to external disturbances, the antenna motor speed can be obtained again by changing the error voltage or changing the resistance. The frequency generator motor detects the speed deviation. Servo amplifier changes resistance according to the deviation, and it changes the impedance between the collector and emitter of the transistor Q901. Instead of the resistance shown in figure 4, impedance R can be changed by the base voltage. The motor speed can be kept stable by controlling the base voltage for the motor speed deviation. The bridge step rectifier consisting of 4 diodes makes current flow through the transistor in the direction shown by the arrow in figure 4. So we'll see that the current will actually flow through the transistor here through this bridge rectifier and change the speed of the motor. So we could have a problem with the servo speed control IC. It could be any of those components in that servo circuit. It could even be the motor itself. The frequency generator might not be working. So that's what we have to check first. We have to check to see whether the actual frequency generator is providing a signal to the amplifier on the servo IC, or servo control board, I should say, which will have the servo IC on it. First things first, I need to get the chassis out of the cabinet. And yeah, this cabinet's kind of crunched in the corner. Don't worry, I didn't do that. This is a client's machine that they rebuilt by pulling parts off of an old machine. The client actually gave me, I've done a number of reel-to-reels for them, they actually gave me one of these machines that had mice and rats and stuff had been into it. Said, here's a reel-to-reel machine for you. And it was sitting here for a couple of years, and I hadn't even got to it. And then they asked for it back. They also asked for back an old turntable. They gave me an old turntable. It was part of a console radio with a record player and stuff on it, but the rest of the cabinet had been trashed. So I had just the drawer that would slide out on this old, I think it was an old Electro-Home radio, and they collected that back so they could rub parts off it as well. And you know what they say about people that give things away and then ask for them back, right? But I didn't need it. I probably would have never rebuilt it because it was in really sad shape. It had rats and stuff get into it. So it was just sitting here collecting dust. So when they asked for it back, because they'd found this one and it was missing parts, I said, here, take it. You can restore the better of the two that you've got, or the better from the two. And they took it back and took parts off it to make this one work, but this one's obviously got issues. We're going to slide out the cabinet here carefully. Got a little fan on the top here. One thing to note on this is a tape recorder, not a tape deck. You see it has speakers in it. So this is actually a tape recorder. The correct term for a tape recorder has speakers. If it does not have speakers, it's a tape deck. So the first things first, let's just check and see if we have speed control. We have 3 speed controls here. 1 7/8, 3 3/4, and 7.5. If these controls work, then we know the servo circuit is working because we've got feedback. It's just a matter of calibrating, and I'm hoping that that's all that it is. I can just calibrate this and it'll be done. So let's just hit the button here, and I see that my scope, I gotta hit the button on here to measure this. Here we go, 3.52 kilohertz. So this should be the control for 7.5. And I can slow it down. I'm almost at 4. I'm on 3.86. Listen to this. If I just push on the board here, I need a bad connection on here. Either that or the control. It could be the reference voltage is a little bit off too, because all 3 of these provide a feedback signal back, but they come off the switch here, but there'll be a reference voltage that is on the wiper for each of them for the different speeds. Just check this out. When I just touch the switch, I do have the schematic for it. Well, what I could get. It's this is the schematic, right? And this is the section of the servo board. But this is actually the IC. I was able to blow that up so we can take a look at these are the 3 trimmers. And as you can see, they go through resistors, R902, R904, and R906, 3.3, 6.8, and 130K for the 3 different speeds, right? 1 7/8, 3 3/4, and 7.5. And they're given a reference. It comes off of 12 volts, which is over, or 8 volts, 8 volts right there off the IC. Got a reference voltage, and it goes down through these resistors and selects your tape speed, and it feeds back through pin number 3. So it's pretty simple circuit. If the reference voltage is low, then it's going to be slow. And what could affect the reference voltage? Well, it could be a connection problem. Looks like there's a voltage divider here, R907, which goes down through and then down through, and there's C903, a little 0.001 capacitor, C904, which is a 10 microfarad, probably the one that the owner replaced. But I think my reference voltage might be a little bit off. it could be one of these parts. It's definitely somewhere in here that our speed is off. It even could be this little C902, a 0.15 microfarad. C902. If this little cap here was just a little bit leaky, then that would pull that voltage down a bit and make the speed a little bit on the slow side. The fact that when I just touch the control, push on the control, everything goes back up though, makes me think we may have a connection problem in here. And that's what I'm going to concentrate on is these solder connections in here. Maybe even give this switch a little shot of cleaner. But right in this area here, that's where I think our fault is going to be, is right in this area right there of the board. We have another servo board for this unit also. This came out of the donor machine that gutted to make this one work, because when they bought this one there was parts missing. So they took back the machine that they gave me. Like, I had this machine complete, but it was in real bad shape because mice and stuff had been in it. And it might have been one that I would have rebuilt at some point, but as I say, the owner of it asked for it back, so they took it away and gutted. So I've got the board. Could be one of these little caps down here, one of these ones that's on the ground side. Could be going bad. They've changed the other caps. I'm going to resolder this board here. You can see some of these connections have already been done. I guess that's where the capacitors were, but I'm going to redo these caps here. Before I do that, I'm going to give the switch a shot of cleaner. We'll clean the switch first. Make sure we're not dealing with just a dirty switch. Sorry I couldn't show you cleaning the switch. It's in behind here. But I just gave it a shot of cleaner. We'll see whether the speed is any different now, whether it's sped up in... still at 3.95. Am I all the way up? Yeah, 3.95. So and the owner of it did change some of the caps on this board, but not all of them. Oh, God. Shut up. Cat wants to play. It's not playtime, it's work time. Every time I sit down, that cat will sit at the door and howl until I go in there and throw his stupid stuffed toy for him, and then he'll shut up for 5 minutes. Alright, let's just see whether I got the need for speed back. It's close, but not quite. We can check some voltages too. Let's just check a few voltages. This is the ground reference here. That's ground. Ask me how I know. I had to count the pins on the IC. So ground is pin 12, which goes right up to right there, pin 12. 12 between pin 12 and pin, what we should have on here, we should have 8 volts on pin 5. So if I look at pin 12, we start at the bottom. Can't read my meter. Still can't read my meter, got the light shining in my eyes. I'm looking for pin number 5. So 1, 2, 3, 4, this is pin 5 here. And on this pin here we have 7.62 volts, and that should be 8 volts. So that voltage is a little bit down. What about the supply voltage? The supply voltage is pin 7, should be 13.5 volts. pin 7 should be this guy up right here. And it's 13.0. So my supply voltage is a little bit low. If my supply voltage is low, that means that other voltages could also be a little bit low. And they are, it's filtered, it's diode 901, and C906 is a 100 microfarad at 25 volts, which is the main filter for the reference, or for the power supply. Our voltage looks to be a little bit low. Also, 8.6 volts on pin 6, or C905. So pin 6, let's look at pin 6. Pin 6 is this one here. 8.3. That's correct. No, it's not. It's supposed to be 8.6. So the voltage is a little bit low on the board. That might be why it's running a little bit on the slow side, if the main voltage is a little bit off. I should have 13 volts on pin 8 and 14 volts on C906. So 13 volts on pin 8, looks like here. Yeah, 13 volts on pin number 8. So let's look at pin number 8. Pin number 8 is this one here, 13.2. Okay, but where's my main filter? Pin 8 is goes through R911 and then to the main source. So D901. I'm kind of looking at this other board to see which is which. Maybe this one will tell me where D901 is. D901 is up top here, right next to C906. C906 is that's the 100 microfarad at 25 volts. It should be this one right up here. 100 microfarad at 25 volts. Is that, did they put the wrong cap in? Let's see here. What do we got here? That's this big one. 100 microfarad, 25 volts. Let's just see what that is. That's been changed. I think I'm barking up the wrong tree though, because I really think that I don't think that voltage being a little bit off. I mean, on the main cap, it's a much smaller cap, but it's still 100 microfarad. The original one was a big one like this, right? 100 microfarad, 25 volts, negative is up top. And when I measure, and there's a new one that's in there, but when I measure it, I'm getting 13 point, what did I say it was supposed to be? It should be 14 volts. I'm getting 13.6. Actually, it should be 14. It should actually, I guess, yeah, it should be 14 volts. Should be 14 volts right there, if you can see that on the paper, or maybe it's overexposed, but should be 14 volts right there on this capacitor, and it's 13.6. So my voltage is certainly a little bit down, and this is fed from somewhere else on the schematic. Let me go back and look at the main schematic and see where that's coming from. It comes back here. That's going back to the power transformer. So that voltage will be dependent on the incoming AC. So that should not affect it. The reference is over. It shouldn't affect it. What will affect it though is if C902 is going a bit leaky, that would certainly cause the voltage to drop a little bit. That's a possibility. C902 is bad. Maybe we'll swap that one from the other board. C902 is this one right here. I'm just going to pop it off, the old one off the board, and we'll pop that on and see, because if that cap starts to go a bit internally leaking, then that will most certainly affect the servo, because it'll load down the line that is what is setting the reference. It'll make all these a little bit low. So I'm just going to pop the board out. It's just held in place by a single screw, I believe. Why is it so dark in here today? Just like today's a dark, gloomy day. It's a dark, gloomy day out today, and it's dark in the shop. I got lights that are out in here. It's just like, it just seems darker than normal in the shop. I'm looking around to see if there's any lights that are burned out. Okay, here's the little servo board, and this is C902 right there. We'll just swap that one out for this other one. And no, I'm not going to spend 20 minutes giving you a lecture on the outside film. Take shots at that one. I think you know what I'm referring to. Nothing personal. It's just an observation of what people on one of the Facebook groups that I am a member of. It's called I Take Pictures of Electronic Components, if you want to follow the group. You'll never see me post in there. I don't think you'll ever see me post in there. I just read what other people put in there. Sometimes the comments are kind of funny. You see some gadgets. Usually it's people posting a picture of something that they don't know what it is, and they're asking the group, what type of part is this? So let's see if changing that cap has increased my speed. Oh, you know, is this 4.2? It's brought my speed up. Damn. Like, that's really, really close. That's 3.9, 4.1. Like, it's shifting slightly, which is to be expected because I hear flutter. What's going on? Why is that hunting? See what the effect of adding an extra capacitor does? It drops your speed. Indeed, both of these caps have increased their value a little bit. One's measuring 0.156, should be 0.15, and the other one is measuring 0.155. So they're pretty close to being in spec. And if the capacitance goes up, then the speed goes down. I don't personally think the IC is at fault, but the IC does play a role in this, and I think the reference might come from the IC. Because I have another one on hand, I'm just going to swap it, just to rule out that the IC is just not providing the right reference voltage for the servo. With great difficulty, I got that chip out. The circuit board in here is literally falling apart. The traces are just in such bad shape because of this thing being as old as it is. So I'm just going to tack in a couple pins here just to hold it, and then we can attach the rest of it there. That ought to hold it there, and one there, and one there. We'll just reattach the rest of these pins. Okay, I'll try it with this IC. Hopefully this IC is good. I don't know anything about it. It was just pulled off this other board, but that way, if it is the reference voltage coming off the IC that was causing the speed to be bad, then that would fix that. If it's the reference voltage, it won't do it if it's anything else, right? But since the IC itself is responsible for so much of the operation of this servo, you got to consider that if the voltages are a little bit off, if the regulator's in the IC, that could certainly affect it. So that's why I swapped it, just because I had one here, and everything else was looking to be okay. I mean, they say the voltage was a little off, so I guess we'll find out pretty quick when I fire it up. It's either going to go up in smoke, or it's going to work, or it's still going to be slow. Let's see what happens. Well, let's see if I've got control now. Oh, good. It was the IC. Cool. So what it was the reference voltage from the IC was wrong. and that was throwing everything else out of kilter. But there we go. I got my 4 kilohertz. I'm just going to calibrate all 3 speeds, and I can do it from this tape. I guess I got to go back to, that's 1 kilohertz there. Let's go back. Okay, that's 4 kilohertz right on the button. Now we can do this one to 2 kilohertz because we're half the speed. And we should be 1 kilohertz for this one. There we go. Two kilohertz right on the nose. 4 kilohertz right on the nose. I'll show you the scope. Here we go. And there we go. Perfect. So what exactly did we learn on this one today? Well, we learned that even when components appear to be operational, and the IC certainly was operational because it was doing its job, it was controlling the speed of the motor. If the motor was too slow, it would speed it up. If the motor was too fast, it would slow it down. It was regulating the speed as it was supposed to. It was getting its feedback from the FG coil, and it was referencing it, and it was outputting a correction voltage. But what was wrong? And if we go back and look at the video from earlier, when I measured my voltage here, my 13 volt reference was a little bit low. Now, you see, this, everything's based on voltage on here. So this is, the diode comes in, this is coming right from the transformer. It goes to another part of the schematic, but it comes from the power transformer. So we have a half-wave rectifier, and we have it filtered through this capacitor C906. Goes through a voltage divider, a little resistor here that drops the voltage down for a reference of 13 volts there, and R910, which is the 39 ohm resistor, 13.5. But what was interesting was the voltage is coming back. The 8 volt supply was a little low, as was the 8.6 supply. Now the 8 volt supply comes off, it regulated inside the IC. Inside here there's a reference, there's a regulator, a Zener diode or something inside here that sends out 8 volts. And that 8 volts comes along this line here, and this one ends up down here on this switch. The switch selects the tape speeds and changes or goes through these selector resistors, variable resistors, to set your speed. These are like your pitch controls to set your fine speed. That reference voltage then is then filtered by a C902, and a C902 could go bad, and that would certainly cause the speed to be off as well. And we tried that. I didn't have the exact value, but I tried some values to see what would happen, and it was changing the speed. From here, the reference voltage comes back up, and it ends up here on pin 3. Now there's no set voltage listed here because this changes. This changes what depending on what speed you're in, depending on what selector switch selects. And that controls the servo. But if the reference voltage is not correct, this case is supposed to be 8 volts. If the reference voltage is not correct, the speed will not be correct. We'll notice that the switch also selects 3 different resistors here, which also changes the voltage going into pin number 10, but it should be 2 volts. But there's 3 different resistor values here that just select this. All they're doing is they're just changing 3 different values, charging up C908. But this also forms part of the speed control circuit. But ultimately, the failure was in the IC, because we tried everything. We tried the capacitors over here. We tried changing their values. That variable resistor here, when you pushed on it, it must have a fault too. It's fine, but when it's at the end of its travel, when I pushed on it, it sped up a bit, so it must be changing its value, and that would change the voltage and cause it to speed up. It only did it on that one control, the 10K control. There's a 10K, a 20K, and a 50K control for the 3 different speeds. It only did it on the 10K, but it's not at the end of its travel now. It's midway on its travel, and the speed is correct. So anyway, there we go. The IC was bad, and say we don't see those happen very often. Usually when these ICs go bad, you have no speed control, right? I've seen these fail before on machines like this that use a servo-controlled AC motor, because that's what this is. This is the transistor here. If we look down here, how this works is it provides an error voltage out of pin number 9, which is normally about 0.63 volt, because you're just bringing the transistor slightly into conduction. And the motor is connected across here. The transistor is connected between ground and it's basically 2 dual diodes. It's a full wave bridge rectifier and 160 volt 10 microfarad capacitor. So there's high voltage on here. And what this does is the transistor starts to turn on, and as the transistor turns on, it starts to bring this bridge out of balance, which increases the AC that's passing through it because of the nature of how it's configured. So AC is on here. This is AC to motor. Right? That's going to the motor, one side of the motor. The other side of the motor is obviously connected to, well, one side of the winding is connected to AC, the other side is connected to here, and of course ground. Anyway, if we look at the other schematic, I think I've got it here, that shows where the motor is. Does it show the motor in here? Where's the motor? There is the motor up there. So if we can zoom the camera in, you'll see that the motor, you got 2 windings on the motor. One's going through a capacitor that generates your phase shift. But one side of the motor is going down to your main power. The other side of the motor comes down this way and ends up right there. And then this one here goes back to the transformer for its power. So this little bridge here with this transistor basically operates like a variable resistor to change the amount of AC that's allowed to pass through here to get to the motor to change the speed of the motor. And the feedback from the motor is picked up from that little coil there and into the IC. And that big dead white space, that's the IC. Anyway, it's not a real complex circuit, but before jumping to conclusions and changing the IC, you got to kind of check the other stuff to see, because any of these support components could have caused it. Now, I probably could have fixed this without changing the IC if I was to go and change some values, which is what some people will do when they can't get the ICs. They'll change some values of resistors just to compensate for it. But in this case, I didn't have to change any parts, just the IC itself. And everything's good. Clear as mud, right? Oh, I thought it was working, but you know what? The auto stop is not working. Let's find out why. There's a switch here that's supposed to, when the switch drops down, it's supposed to stop everything, but it's not. Again, this is one that the owner of it has already been into it and done work. In this case, though, I think this is probably going to be something to do with the auto stop lever. Maybe not quite low enough, going low enough. So auto stop activates a little micro switch that's right in behind here. I don't know if you guys can see it or not, but there is a little tiny micro switch in there that when that lever drops down, that little micro switch that's right in here is supposed to open. And when the lever drops, it's supposed to go. Maybe something is bent and it's not quite dropping low enough. Well, let's just give it a hand. Let's just pull this lever down a little more and see what happens. Oh, okay. That's all it is the switch is not being dropped quite low enough. I don't know if you guys can see the twist, but it's not going down low enough to open the switch quite enough. But just a little more like that and it will. I think I'll probably have to pull the front off of the unit just to get at it, because I can't really get at it from here with this cover on. So if I pop the cover off, I should be able to get to the switch and adjust it. Don't forget the these got to come out. And this whole face should just pull off. So now the whole face will fall off of it, and I can get to that switch that I need to get to, which is right back here. The auto stop switch is right here. To do that, I will actually remove the Jesus clip on the back here so that I can remove the entire arm. I think I can lift the entire arm out so that I can kind of straighten it a bit. It never gets old why we call these Jesus clips, because when they fly away, that's what you're saying. Jesus, did you see where that clip went? Alright, lift this out of here and try to straighten it a bit. Just give it a bit of a bend up so that it's not going to be so low. To lay the unit on its back to get this piece back on, otherwise the meters will never line up properly. We'll just test to make sure that the auto stop works before putting the back on it. I'll give it a final test. So hold that up. There, that's how it's supposed to work. Okay, before I send it out, let's put it on the right speed. I haven't threaded it right, that's why it's making noise. Reverse direction. Yep, sounds good to me. Tape counter's working? Good. Make sure everything's working, right? I'll do a test recording before I send it back. I'll just grab another tape, make sure the auto stop works, which it does, which is one of the things that was brought in for, was the auto stop not working. So I'll grab a tape I can record on. We'll make a quick test recording. I'm going to throw this one together and move on to other stuff, because I certainly do have other stuff to work on here. Besides having some stuff of my own, I just picked something up at the post office. I don't even know what it is. I haven't even opened the box yet. It's still sitting in a box. So I do have other stuff to work on. We'll just do a quick test recording on this one and get it out of here. I think the controls need to be cleaned on here. Let's give them a shot of cleaner before I put this thing together. Hard for you guys to see what I'm doing because the controls are near the front, but trust me when I tell you I'm spraying the controls down. You have to trust me. Hard to get at these controls. They're wide open. Blinded myself with a bloody flashlight. Get that control. We'll see how it sounds. Put the power back on. See whether I got any cleaner in there. I think I did. Yeah. The other control is way over here. Okay, got the level controls clean. Let's set our levels. All right, record, go, and I can put these to. Hear the recording coming back. Yeah, I know. I didn't thread it right. Too bad. There you go. Okay, it's working. Everything's working on it now. Really do need to get some proper reading glasses. I hate these things. These are just like this. I don't normally wear glasses. I use these when I'm working on electronics only because it makes seeing fine components like for soldering and stuff a little bit easier. I don't have to wear glasses for reading. I don't have to wear glasses for working on the computer, reading the phone, anything. I can see perfect. Distance, close up, everything. I had laser surgery, I don't know, 15 years ago, I guess. I used to be blind as a bat, but that's beside the point. I'm not now. And I only use them, I only use the cheaters for when I'm working around electronics or when I'm splicing fiber optic, when I'm terminating fiber optic at work for my day job. I use them for that just because, well, you're terminating fiber. It's freaking small. Almost impossible to see. But I use them and these are not right. Like these are +2, which I wouldn't need +2 even for reading glasses. Probably +1 or 1.5 would be more than adequate. These work really good though when I'm working on electronic stuff. The problem with it is if I don't take them off and I go to walk somewhere, I tend to fall flat on my face because I trip on everything. Because everything beyond a few feet is out of focus. Kind of a pain. I keep remembering to take them off and I'll trip over things like the camera. I'll trip over the camera tripod. And then bad words are spoken. But having been someone who wore glasses and contact lenses from the time they were, I don't know, I forget, I think I was 12 or 13. We'll say 13. But let's just say for a while. From the time I was 13 until the time I was like 47, I think it was 47 when I finally broke down and dropped $3,000 or more than $3,000. 30, I think it was $3,300 is what it cost me. And then I got to say goodbye to wearing glasses and contacts forever. And I tell you, the best money I ever spent in my life. For those wondering how much time I spent on this today, I started at 12:12. It's now 3:15, so about 3 hours. Okay, I'm just going to throw the screws on this one. I don't think you guys need to watch me put the last 4 screws in. So I'll say thanks for watching. We'll catch you in the next one. Bye.